Okay, let's start with the basics: continuous integration. Imagine a team of developers working on different parts of an application. It's easy for these pieces to become incompatible over time. CI is all about preventing that from happening. It's essentially a daily habit where everyone integrates their code changes into a central repository, usually Git, multiple times a day. Each time someone pushes, the system automatically builds the software and runs automated tests to catch any problems early on. The goal is super fast feedback so developers can quickly fix issues instead of dealing with huge integration nightmares down the road. It's really about reducing risk and improving overall quality. Okay, let's talk about continuous delivery. It's a really important concept in modern software development. Basically, it's all about making releasing new code as smooth, predictable, and reliable as possible. Instead of hoping for one massive release every few months, CD allows you to deliver small changes, think features, or fixes much more frequently, often multiple times a day. It's not just about the deployment itself, it's the whole way of thinking about how we get software into our users' hands. The key is automation, automating everything from building your code all the way through to deploying it. And by delivering in smaller chunks, you get faster feedback and can catch problems early on. Okay, let's talk about continuous deployment. It's a really important part of understanding the whole CI/CD picture. Basically, it's all about automating the process of getting your software changes directly into your users' hands. Instead of big, infrequent releases that often involve manual work and potential headaches, CD focuses on small, frequent deployments. It builds upon continuous delivery, which is where we automate the build and testing stages and automatically pushes those tested updates out to production. Think of it like a smooth, continuous flow of new features and bug fixes directly to your users. Okay, let's talk about why you'd actually want to implement a CI/CD pipeline. The biggest benefit is often speed. It drastically cuts down the time it takes to get new features or bug fixes out to users. Because everything is automated, there are fewer manual steps, which means faster releases. Plus, because you're constantly testing throughout the process, bugs are found much earlier than they would be with traditional release cycles. This leads to higher quality software and reduces the risk of major issues when new versions drop. And it frees up developers' time too. They don't have to spend as long on repetitive deployment tasks. Okay, so let's get practical here. What tools have you actually used to build and deploy software? There are a ton out there, but some of the big ones include Jenkins, which is a really mature open source automation server. Then we've got GitLab CI/CD and GitHub Actions. These are fantastic because they're built right into Git repositories. Circle CI is another popular cloud-based option that's really easy to get started with. And if you're working within the Microsoft ecosystem, Azure DevOps Pipelines is a solid choice. Finally, AWS Code Pipeline is great for those deploying on Amazon Web Services. When discussing these tools, it's not enough just to name them. Be ready to talk about how you use them, like what kind of test you ran and how you customize the settings. Okay, let's talk about continuous delivery and continuous deployment. They are often confused. Essentially, both are about streamlining how we release software, but they differ in where the human element comes into play. Continuous delivery means our code is built, tested, and packaged ready to go. Think of it like having a perfectly prepared launchpad. But someone still needs to manually trigger the actual deployment. On the other hand, continuous deployment takes that a step further. It automates everything so changes are deployed directly to production without any manual approval. It's like an automated rocket. Once it passes all its checks, it launches itself. They're both important parts of a good CI/CD pipeline. Okay, so imagine a continuous flow for your software changes. It all starts when a developer commits their code, usually to something like Git. Then a CI server kicks in automatically. This server builds the application from that code, creating an executable or a container image ready to go. After that, it's time for testing. Automated tests run to make sure everything works as expected. If all tests pass, then the deployment stage starts, pushing the app to a staging environment first and eventually to production if everything checks out. Finally, monitoring tools are constantly watching the application to ensure it's running smoothly. Okay, let's talk about what usually goes into a CI/CD pipeline. It all starts with developers committing their code to something like Git. That's our source control. Next up is the build stage. The code gets compiled and packaged into something ready to use. Then comes testing, lots of automated tests to make sure everything works as expected, including checking for potential problems before they even reach users. After the tests pass, we deploy the software, either to a staging area or directly to production. And finally, it's important to monitor the deployed application to see how it's performing and gather feedback so we can continuously improve. Okay, let's talk about version control, specifically how it fits into our CI/CD pipelines. Basically, every time a change is made to the code in Git, the entire pipeline kicks off again. The tool pulls the latest code from your repository, builds it, runs tests, and if everything checks out, deploys it. Version control isn't just about tracking changes, it's actually fundamental for being able to roll back problems quickly, maintaining a clear history of what happened, and letting multiple developers work together smoothly. When you talk about CI/CD pipelines in an interview, this is a core concept they want you to understand. Okay, let's dive into how you'd handle build automation in your CI/CD pipelines. It's really about systematically taking code and turning it into something deployable. You'll want to be comfortable discussing tools like Maven or Gradle. They are super common for managing dependencies and automating builds. Think about breaking down the process into stages, like compiling the source, running tests, and packaging everything up as a deployable artifact, maybe a JAR file or even a Docker image. And crucially, how do you handle those environment-specific configurations? Making sure your build works smoothly across development, staging, and production is key. Okay, let's talk about automated testing and how it fits into our CI/CD world. Essentially, we're talking about using scripts or tools to run tests automatically, no manual clicking needed. This is hugely beneficial because it gives developers instant feedback on whether their code changes have introduced any problems. Think of it like a rapid check-in system. We've got different types of tests too: unit tests, which focus on individual parts, integration tests to make sure everything plays nicely together, and end-to-end tests that mimic how a real user would interact with the application. Okay, let's talk about testing in CI/CD pipelines. It's super important. You don't just want to build the code, you need to verify that it *works and is actually good. We need a layered approach. First, we have unit tests. These are like mini checkers for individual pieces of your code. Then integration tests make sure those pieces fit together smoothly. End-to-end tests simulate how a user would interact with the whole app, giving you confidence that everything's connected correctly. UI/UX tests check that it looks and feels right to the users. We also need performance tests to see if your system can handle the load. No one wants a slow or crashing application. And finally, don't forget security testing. Protecting your app from vulnerabilities is absolutely key. Okay, let's talk about rollbacks. How do you undo a bad deployment? It's absolutely vital to have a plan in place. First, you need clear triggers. What signals you that something went wrong? Then, decide what you're rolling back: specific code changes or even an entire environment. There are a few common methods: blue-green deployments, where you have two identical environments and swap traffic when needed; canary releases to test with a small group first; and feature flags, which let you turn things on and off without deploying new code. Most importantly, automate the rollback process using your CI/CD tools so it's fast and consistent. And don't forget to verify everything after the rollback. Okay, let's talk about blue-green deployments. Think of it like having two identical copies of your website or application. One is live, and the other is just waiting in the wings. Before you release a new version to everyone, you deploy that version to the green environment. You thoroughly test it there, making sure everything works perfectly. Then, with a quick switch, you redirect all the traffic from the old blue environment to the brand new green one. It's super helpful because if anything goes wrong after the release, you can instantly flip back to the stable version without anyone noticing any downtime. Okay, let's talk about canary deployments. It's a really smart way to release software, and it all boils down to this. You don't just launch a new version to everyone at once. Instead, you roll it out to a small group of users, maybe just 10% first. This lets you check if everything is working smoothly in the real world before fully deploying it. It's like a mini test run. You closely monitor how that small group is using the new version, and then, if it looks great, you slowly increase the percentage of users getting the update until everyone is on board. It helps minimize risks and gives you valuable feedback early in the process. Okay, let's talk about how we handle sensitive stuff like passwords and API keys in our CI/CD pipelines. It's absolutely crucial that we don't just stick them directly into our code or configuration files. That's a recipe for disaster. We want to use dedicated tools, things like HashiCorp Vault or the secret management services offered by our cloud providers, to keep those secrets safe and secure. Another great option is using environment variable substitution within our pipeline definitions. This allows us to inject values dynamically at runtime without hard-coding any sensitive information. And remember, rotating your secrets regularly and following the principle of least privilege are vital for maintaining a strong security posture. Okay, let's talk about artifacts. Think of them as the finished products of your CI/CD pipeline, the actual deployable bits. These could be compiled code, package containers, or even just configuration files. It's crucial to understand what these are and how they are kept track of. CI/CD tools automatically build and store these artifacts in a secure repository. This ensures that you always have the right version available for deployment, preventing issues caused by inconsistent environments. Okay, let's talk about pipeline as code. Think about how you used to set up your CI/CD pipelines, probably a lot of clicking around in tools like Jenkins. That setup was often spread out across different files and scripts, making it a real headache to manage, especially when you needed to share them with others or ensure everything worked consistently. Pipeline as code flips that approach on its head. It's all about treating your entire pipeline, the steps, the tests, the deployments, just like any other piece of software. You store those definitions in version control, like Git, allowing you to track changes, collaborate easily, and make sure everything is repeatable. This leads to a lot of benefits: consistent deployments, easier teamwork, and better overall automation. Okay, let's talk about keeping your CI/CD pipeline safe. It's super important to think beyond just getting things built and deployed quickly. First, absolutely never put secrets like passwords or API keys directly in your code. Use the dedicated secret manager tools like Vault are great for that. Next, run static code analysis early on to catch vulnerabilities before they even make it to production. Then, regularly scan your project's dependencies for known issues, because outdated libraries can be a major security risk. When you're managing infrastructure with things like Terraform, pay close attention to those templates and scan them for misconfigurations too. Finally, limit access within the pipeline. Only give people the permissions they absolutely need, and consider using immutable infrastructure and rolling deployments to reduce your attack surface. Okay, let's talk about handling dependencies within your CI/CD pipelines. It's a really important topic because inconsistent dependency versions can lead to flaky builds and unexpected errors in production. The good news is there are several solid approaches you can take. First off, package managers like npm, pip, or maven are essential for defining and controlling what libraries and tools your project needs. But it doesn't stop there. These managers often create lock files, such as package lock, JSON, or pip file lock. These files essentially pin down the exact versions of all dependencies, so everyone working on a project builds with the same set of components. Another powerful technique is containerization using Docker. This packages your entire application and its dependencies into a self-contained environment. Finally, build tools like Gradle or Ant often have built-in support for dependency management, streamlining the process even further. Remember to always commit those lock files. They are vital for ensuring consistent builds. Okay, let's talk about build triggers. Think of them as the little sparks that get your CI/CD pipeline going. They are events like a code commit to your repository, or someone creating a pull request that automatically tell the system, hey, it's time to build and test. There are several common types: code pushes, pull requests, scheduled builds, and even manual triggers. Essentially, the CI/CD tool is always watching for these events, and when one happens, it kicks off the entire build process. Okay, let's talk about speeding things up in our CI/CD pipelines. A really powerful technique is called parallel execution. Think of it like this: instead of waiting for one step to finish before starting the next, we can run multiple steps at exactly the same time. This dramatically reduces the overall build and deployment time. It's especially helpful when you have stages that don't depend on each other, like running tests alongside code analysis or building different versions of your application at once. Just be mindful to make sure those stages are actually independent, because if they aren't, things can get messy quickly. Okay, so let's talk about keeping an eye on your CI/CD pipeline. It's not enough for a build to just finish. You need to understand how it finished. We start with some key metrics like how long each stage takes, the success rate of builds and deployments, and how much you're getting done over time. Tools like Jenkins or GitLab CI often have dashboards built in, but platforms like Prometheus and Grafana can give you even deeper insights. Don't forget logging. Centralized logging is your friend when troubleshooting. And most importantly, set up alerts so that you're immediately notified if something goes wrong, allowing you to quickly investigate the root cause. Okay, let's talk about caching in CI/CD. It's a really important technique for speeding things up and saving resources. Basically, caching is like creating little memory shortcuts within your pipeline. Instead of having to redo the same work over and over again, if something has already been calculated or built, it can be retrieved from this temporary cache instead. This dramatically reduces build times and costs, allowing you to iterate much faster and scale your pipelines more efficiently. Okay, so let's talk about some real-world difficulties when setting up CI/CD pipelines. A huge challenge often comes from dealing with really complex code bases, especially if they have old parts or a lot of interconnected systems. Then there's the whole thing of managing our infrastructure through code itself that requires a good understanding, and mistakes can seriously disrupt things. We also run into issues with tests. Making sure we're testing everything properly while still keeping the process moving is tricky. Security is another big one. You need to scan for vulnerabilities as part of your pipeline, but it can add time. And don't forget about rollbacks. If something goes wrong, you need a way to quickly undo your deployment without causing more problems. Finally, visibility and monitoring are key. You need to be able to see what's happening in the pipeline and spot any issues as they arise. Okay, let's talk about designing CI/CD pipelines specifically for microservices. The key is to think modular. Each service should be able to roll out independently without impacting others. We need to start with robust health checks to immediately catch any issues after deployment. Then we'll want independent deployments, meaning you can update one service without touching the rest. Testing is crucial. Automated unit and integration tests for each microservice are a must. And don't forget about managing your service configurations centrally. This keeps things consistent and secure. Finally, make sure your pipeline integrates with your service discovery system to ensure traffic gets routed correctly after any changes. Okay, let's talk about infrastructure as code. Think of it like treating your servers and networks just like any other piece of code stored in a version control system. Instead of manually setting things up through the Cloud Console, we write files that describe exactly what infrastructure we want. Tools like Terraform make this possible. This leads to huge benefits. You can track changes, automate deployments, and make sure everything is consistent across different environments. The really cool part is integrating it with our CI/CD pipelines. Whenever code changes are pushed, the pipeline automatically generates or updates the ISC code, triggering a deployment. Okay, let's talk about self-hosted runner agents, a really important concept when it comes to CI/CD. Think of them as little workers that actually do your builds. Most CI/CD systems rely on cloud runners by default, which are managed by the platform itself. But sometimes you need more control and flexibility. A self-hosted runner agent is just software that you install on your own servers, giving you complete control over the environment where your pipelines run. It's great for situations where security or cost are major concerns, or if you have specific regulatory requirements to meet. Just remember, with self-hosting comes responsibility. You're in charge of maintaining those agents. Okay, let's talk about how we manage different environments like development, staging, and production within our CI/CD pipelines. It's really important to keep these separate. Think of it like building blocks. We usually start by creating individual pipelines for each environment, so changes in dev don't accidentally break anything in production. Then, we need consistent configurations across all those environments, which is where tools like Ansible or Chef come in handy. They help us make sure everything is set up the same way everywhere. Feature flags are also super useful. They let us turn on features in staging and even production without actually deploying new code, reducing the risk of problems. Finally, using branching strategies like separate branches for each environment can really improve control. Okay, so you've got your pipelines set up, that's awesome. But managing them can get complex. That's where orchestration tools step in. They're basically the brains of the operation, making sure everything runs smoothly and in the correct sequence. They handle things like dependencies between stages, scheduling triggers, and even deal with errors if something goes wrong. Think of it as a conductor leading an orchestra, ensuring all the instruments play together harmoniously. We've got some popular examples like Jenkins, GitLab CI/CD, Azure DevOps, Circle CI, and GitHub Actions. Okay, let's talk about database migrations in your CI/CD pipelines. It's super important that your data stays consistent as you deploy. We treat our migration scripts like any other piece of code. We version control them with Git, and we make sure they get reviewed before merging. Before pushing changes to production, we always run the migrations locally on a dev or staging environment using database testing frameworks to verify everything is working correctly. Then, we integrate these migrations into our CI/CD pipeline, so they automatically execute whatever code changes are made. And crucially, we have a rollback strategy in case something goes wrong, maybe reverting back to the previous schema version. Tools like Liquibase and Flyway can really simplify this process by handling all the execution and dependency management for you. Remember, migrations should be idempotent, meaning running them multiple times won't break anything, and it's important to wrap them in transactions so that either everything applies or nothing does. Okay, let's talk about getting our containerized applications live. We need a robust strategy for both testing and deployment. First, we use a layered approach to testing, starting with unit tests to check individual pieces, moving up to integration tests, ensuring everything works together, and finally, end-to-end tests that mimic real user interactions. Also, don't forget container health checks. These are super important for verifying the containers themselves are running correctly before we even think about deploying them. When it comes to deployment, we often use rolling deployments, which gradually replace older versions with new ones, or blue/green deployments where we maintain two identical environments and switch over when things are stable. And critically, almost all of this is automated using tools like Jenkins or GitLab CI/CD. Okay, let's talk about continuous feedback. It's really the heart of effective CI/CD. Think of it as a constant conversation between your development team and your users and even your monitoring tools. It's not just about running tests, it's about actively collecting insights from everywhere, what users are saying, how the app is performing under real-world conditions, and even getting feedback on changes during code reviews. The goal is to use that information immediately to make improvements, rather than waiting until the end of a development cycle. Okay, let's dive into smoke tests. They're super important for CI/CD because they are like a rapid health check on your code after it gets built. Basically, you run a small set of tests to make sure the core functionality is actually working, kind of like asking, is this thing even running? They typically happen right after the build stage in your pipeline, which means any major issues are caught early before more complex testing kicks in. Think of it as a quick sanity test. Okay, let's talk about adding approval gates into your CI/CD pipelines. Think of them as checkpoints. They're a really important way to ensure quality before you actually deploy something live. Basically, you define what needs to be approved. Maybe it's passing all the tests or having a successful code review. Then, within your pipeline tool like Azure DevOps or GitLab CI, you set up these gates. You can have manual approvals where someone has to click approve, or automated ones triggered if certain conditions are met. It's vital that reviewers get clear notifications and can easily provide feedback. A good approval process isn't just about saying yes, it's about ensuring everyone is on the same page. Okay, let's talk about feature flags. They're a really powerful tool in CI/CD pipelines. Basically, they allow you to turn features on or off while your application is running in production. Think of them as conditional statements in your code. If this flag is set, then run this part of the code. It is super useful for controlled releases, like gradually rolling out a new feature to only a small percentage of users at first, letting you monitor performance before it goes live for everyone. You can also use them for /B testing, showing different versions of a feature to see which performs better. And perhaps most importantly, they give you an emergency off switch. If something goes wrong with a new feature, you can quickly disable it without needing to roll back your entire deployment. Okay, let's talk about what happens when your CI/CD pipeline throws an error. It's totally normal, things break. The first step is always to figure out exactly why it failed. Use your logs and monitoring tools to pinpoint the problem stage quickly. Then think about retries. Automated retries can handle some temporary glitches, like a network hiccup. But don't retry everything, only those issues that are likely to resolve themselves. For persistent failures, you'll want a dead letter queue. It's a place to send items that couldn't be processed so they can be looked at later. And crucially, have a rollback plan ready in case the deployment introduces new problems. Finally, always analyze those failures and find ways to prevent them from happening again through better testing or dependency management. Monitoring is key. You get alerted as soon as something goes wrong. Okay, let's talk about ephemeral environments in CI/CD. Basically, they're like temporary workspaces. Think of them as a clean slate for each build or deployment. They're spun up just when you need them, do their job, and then disappear automatically. This is really useful because it keeps everything isolated, so one run doesn't mess with the results of another. It also helps ensure that your deployments are consistent and predictable. Tools like Kubernetes help us manage these temporary environments easily. Okay, so let's dive into how code quality plays a vital role in our CI/CD pipelines. Imagine your pipeline like an assembly line. You want everything built right, don't you? Code quality checks are essentially the gatekeeper. They aren't just about finding bugs after the fact, they are about preventing those problems from ever making it through. We use things like static analysis tools to scan code for potential issues without actually running it. Think of them as looking for red flags. Then, we have unit tests. These are automated tests that make sure each individual piece of your code is working correctly. We also track our code coverage to see how much of the codebase we've tested. Finally, enforcing consistent coding styles through linters and style guides makes the code easier to read and maintain. By integrating these checks early in the pipeline, we catch problems quickly and build more reliable software. Okay, let's talk about securing those third-party components you're using in your projects. They're super common, but they can also be a source of potential problems. The key is to proactively identify and address vulnerabilities. First, we use dependency scanning tools like Snike or OWASP Dependency Check, which constantly check your project for known issues. Next, it's great to generate an SBOM, essentially a detailed list of everything in your app with its versions. Then, we avoid vague version ranges like greater than or equal to, and instead pin specific versions for stability and to prevent unexpected updates from introducing new risks. Regularly updating those dependencies is crucial, but always test thoroughly afterward. And finally, keep your dependency manifest, things like package JSON, stored securely with limited access. Okay, let's talk about getting notified when things happen in your CI/CD pipeline. It's really important to know immediately if a build fails or a deployment goes wrong. There are several ways you can do this. Webhooks are super popular. They basically send a message directly to other services like Slack or Microsoft Teams whenever something interesting happens. You can also set up email alerts, which is simple and effective for critical events. Status pages are great if you want a single place to track the overall health of your pipeline. And don't forget about monitoring tools. They let you watch key metrics and automatically send alerts if things go outside an acceptable range. When setting this all up, think about what kind of notifications are most important. Critical failures should always get top priority, and make sure different people receive tailored alerts based on their roles. Okay, so when it comes to CI/CD, we need to make sure the whole application works together smoothly. That's where end-to-end testing comes in. It's like taking a full trip through your app as a user would. We often use integration tests to verify that different parts of our system are talking to each other correctly, and then we build out complete user journeys, simulating a real interaction from start to finish. Contract tests can also be helpful for ensuring consistency between services. Tools like Selenium or Playwright are great for automating browser testing, while Postman is useful for verifying API interactions. Remember to use different environments in your tests to make sure everything behaves as expected. Okay, let's talk about artifacts. Think of these as the packaged results of your build process, things like Docker images or compiled code. It's really important that we manage these well between our builds and deployments to ensure consistency. We use dedicated repositories like Nexus or Artifactory for this, and a good naming convention is essential, something clear that tells us exactly what it is and where it came from. Layered artifacts can also help make things more reusable, while immutable deployments mean we're always deploying the exact artifact built during the successful build process. Okay, let's talk about monorepos. Essentially, they're a single repository housing multiple projects. Think of it as one giant toolbox for your code. This is really useful when you have several related applications or libraries because it simplifies collaboration and ensures consistency across teams. Now, how does CI/CD fit in? Well, with a monorepo, you can make atomic changes, meaning changes that affect multiple projects are all bundled into a single commit. This means your CI/CD pipelines can build and test the entire monorepo as one unit, guaranteeing everything plays nicely together. Plus, because shared libraries and packages live in a central location, updates automatically propagate to dependent projects, making maintenance much easier. Okay, so when discussing CI/CD pipelines, it's really helpful to understand the difference between declarative and scripted approaches. Think of a declarative pipeline as telling the system what you want, like I need a build, then tests, and finally deployment. The tool figures out how to get there. On the other hand, with a scripted pipeline, you're giving very specific instructions: first do this step, then that step. They both achieve the same outcome, but they have different levels of control and maintainability. Declarative pipelines tend to be easier to read and update as your project evolves. Okay, let's talk about how to speed up a sluggish CI/CD pipeline. It's a common challenge. The first step is figuring out where the slowdown is. Use monitoring tools to find those bottlenecks. Maybe your builds are taking forever, or testing is dragging things down. Then we can look at ways to make things run faster, parallelize as many steps as possible, like running multiple tests simultaneously. Optimizing build times by reducing dependencies and caching artifacts also helps a lot. Don't forget about test optimization. Prioritize your tests and consider scaling up your infrastructure if needed. Continuous monitoring is key. Keep an eye on performance and adjust your pipeline over time to keep things flowing smoothly. Okay, let's talk about tackling CI/CD for legacy systems. It's a really common interview question, and it's important to show you understand the nuances. The key is to avoid overwhelming yourself or the team. First, you need to really assess what you're dealing with. Understand the application structure, how much testing exists, and what parts are most important for business value. Then think about using something like the Strangler fig pattern, Replace bits of the old system with new ones gradually. Don't try to rebuild everything at once. After that, focus on automating tests, starting with unit tests and working your way up. And finally, consider containerization or simpler deployment strategies depending on your needs. Let's talk about how we measure the health and speed of our CI/CD pipelines. There are several key metrics that can really tell us a lot. First, there's cycle time, basically how long it takes from when you commit your code to when it's actually live in production. Shorter is always better. Then we have lead time for change, which looks at the entire process of getting a change into production. Next up is throughput, which measures how many deployments or changes we're successfully delivering over a specific period. Of course, failures are something we want to minimize, so failure rate is really important. We also need to keep an eye on build time and test execution time. Long waits, they can slow down the whole pipeline. And finally, don't just collect these numbers, use them to identify and fix bottlenecks. Thank you for watching.